Let's continue with our line integral concept. So we are going to be answering this problem, which is asking us to find the work done by this force over the straight line from -1, 2 to 3, -2. All right, so we know that the line integral, if you have a force field, then work is going to be defined as the following. So for a force field, our work is the line integral along the curve C of the force dotted with its tangent, unit tangent vector times ds. Now we are going to rewrite this so we know how to evaluate this better. So we know that since this is a unit tangent vector and ds is arc length, we can rewrite both of these components as follows. So we can write this as the integral along the curve C of our force F dotted with, now t hat, that's the unit tangent vector. So suppose we create a smooth parametrization of the curve C, then t hat is going to be the derivative of r of t divided by its magnitude, because that's how you get the unit tangent vector, times ds. Well, we know that ds is defined as the magnitude of r prime of t times dt. Now here, if you simplify this, we know that these two components are going to cancel, and this integral can be simplified as the integral along the curve C of f, which we are going to rewrite dotted with r prime of t dt. And you can simply rewrite this as, in a simpler version, this is the integral along the curve C of f dot dr. So that is the simpler way to rewrite this work integral. So instead of looking at this, we're going to be using this to evaluate, which you have to be mindful that where f is actually f of r of t. So we're going to evaluate f at our smooth parameterization of curve t represented by r of t, and c will also be the curve that we're talking about. And this is, of course, the derivative. So hopefully you understand these notations. Now let's take a look at this problem. So we're going to parameterize the curve C, which is a line segment from these 2 points. So suppose here is the first point. Let's call that -1, 2, and we're going in this direction. So the next point is 3, -2. So we need to represent this as a vector valued function. So our C is going to be r of t, which is represented by, so the x component. So since we're starting at the point -1, 2, the initial point is at -1 for the x component plus the direction. So that's going to be 3 minus -1, that'll be 4 times t. And then the y component will have its initial point at 2 plus the direction. So that would be -2 minus 2, that's -4 times t. So I'm just going to go ahead and write -4t. And we know t is going to go from 0 to 1. So that's our smooth parametrization of the line segment. Now we're going to go ahead and compute its derivative because we're going to need that for our integral. So take the derivative, that's just the direction. So for the x component, we have 4, the y component, -4. All right, so let's go ahead and evaluate. So here, I'm going to rewrite the integral for you one more time. So work, it's going to be the integral along the curve C of f dot dr, which is really the integral from some a to b, which are the t values, of f evaluated at r of t times dr. So I'm just going to write it this way, r dotted with r prime of t dt. So that's how you rewrite the integral. Now we need to figure out what this piece is. We already know, I'm sorry, I forgot the derivative. So this is r prime of t. So we need to find what is f of r of t is. So we take our field right here, and we're going to evaluate each component at our function r of t. So for x, we're going to sub in this, and for y, we're going to sub in that. So let's go ahead and do that. So f of r of t, so we know that f of r of t, that's going to be, so f is given as x times y I component. So we're going to have x times y. So the first component is x times y. So that will simply be this times that. Remember, you're expressing everything in terms of t. So x times 1, that's -1 plus 4t. Y is 2 minus 4t. And then the y component of our field, it's y minus x, that's the j. So y minus x, y is, in r of t is 2 minus 4t. Y minus x, x is -1 plus 4t. So here's our y and here's our x. I just substituted them into the field. This is f of r of t. Now let's simplify this carefully. So this is equal to, for the x components, we're going to go ahead and distribute. You get -2, and then -1 times -4, that's +4. So we get +4t, and then 2 times -4, +4t, that's +8t, minus 16t squared. With little combining like terms, this is going to give us 12t, and then minus 16t squared, that's the x component. And for the y component here, we just need to distribute out the negative. So if I do that, I'm going to get 2 plus 1, that will be 3, and then minus 4t. So minus 4t from the first component, we have -8t. All right, so that's our f of r of t. Now we're going to sub that in here into the integral, and r prime of t is right here. We're going to sub that in here, and we're ready to go. Okay, so let's go ahead and take it down here. So we have our work. This is going to be, so let's keep it down here. This is the integral from t values ranging from 0 to 1. And f of r of t, that's the last line you see above. That's -2 plus 12t minus 16t squared. 3 minus 8t for the next component. We're going to dot this with r prime. So again, r prime is right here, 4 minus 4 comma -4 dt. So we perform the dot product. So for dot product, we take this, multiply to the first component, and then we take the next component, multiply to the next component of that vector, and we add them all up. So we have 4, the integral from 0 to 1 of 4 times -2 plus 12t minus 16t squared minus 4 times 3 minus 8t dt. So that's how the integral will look like. Okay, so a little bit of calculation to do. So now let's go ahead and distribute and combine. Here we go ahead and distribute this. Here we go ahead and distribute that. So this is going to give us the integral from 0 to 1. 4 times -2, that's -8. And then we have 12 times 4. That's going to give us 48t minus 16 times 4. That's going to give us about 64t squared. And here we distribute the negative. So we have -12 plus 32t dt. Okay, so carefully multiplying these out. Now let's go ahead and combine some like terms. So here we can combine these components. So we have 12 plus 8, that's going to give us -20. So we're integrating 0 to 1 of -20. The next like term we see that is 48t and 32t. So we're going to go ahead and add them up. So this will give us positive 80t, and then there's no like term for 64t squared dt. Okay, I hope you got the same values as me. Let's continue working. So now we integrate. So integral of -20 respect to t, that's -20t. Integral of 80t respect to t, that's 80t squared over 2, minus the last components, we get -64t to the third over 3, and we're going to evaluate this from 0 to 1. All right, so we plug in the upper limit of integration. So I can simplify the numbers. So for example, 80 divided by 2, so we can simplify that. So the numbers are reduced. This is going to be 40. and then 64 divided by 3. I'll just keep it in that form. So I guess that's okay. So let's go ahead and plug in the 1. So we have negative 20 times 1, that's negative 20, plus 40 times t squared, that will just be 40, minus 64, 1 to the third, that's 1 over 3. And as you plug in 0, you're going to get 0, so just that. So combining our numbers, we have 20 minus 64 over 3, and you put them in common denominators, you'll get your simplified answer as negative 4 over 3. All right, so that's the work done for this particular example. I hope this makes sense. Take care, guys.